Good morning. Today I am going to present a video presentation on the topic QR decomposition. I am Deepika R from AIDS department, second year. So today I am going to explain QR decomposition with a code. So we have a question: write the algorithm for QR decomposition using Graham's commutative method. So this is the given question. This is the given matrix. We are supposed to construct a Python program in order to perform QR decomposition using the method Graham's commutative. So this is the given matrix, and we are supposed to convert this particular matrix into two different matrices. There is Q and R matrix using several steps. So this is the given code. So the first line of the code is used for importing NumPy. NumPy is actually used to perform various and several operations in a particular Python code. And the second line is def QR decomposition of A. So this is a function definition. We are defining a function QR decomposition with the matrix A. So A is an argument here. Third, we are assigning the matrix dimensions. N is the number of rows and M is the number of columns, and in the matrix A. Third, we are in the third step we are initializing the matrices. So these two matrices we are initializing np empty n comma n and np empty n comma n. So we are using this particular empty argument because we are supposed to get an empty matrices, because we are going to create we are going to perform operation in such a way that we will be obtaining a Q and U matrices. So initially the two matrices should be empty. So the Q will store the orthogonal basis vectors, and U will store the intermediate vectors. And then in the 11th and 12th line of the code, we are assigning the first column of Q. So the first column of U is set. Here the first column of U. So this colon will define colon comma 0 will define the first column of U, and this will define the first column of A. So we are assigning, we are setting Q first column of U to first column of A, and then in the and then same as the U, we are here we are getting the value of Q. Q is obtained by normalizing the first column of U. So for normalization we are taking the first column of U and we are dividing it using this particular command np.linearalgebra and the first column of U. So this will be this particular command is used to obtain the Q in the normalized value of Q, and the for loop, and the for loop is mainly constructed to define the Graham's commutative method. So the outer loop iterates over each column of I, and the inner loop, so this outer loop will iterates the each column of I, and this inner loop will computes the projection of current column of A, that is A, and the first column of U will be this particular command is states that it gets subtracted, it gets reduced in each of the steps. So after orthogonalizing the U, this particular U, it is normalized and it is stored in in the queue. This particular thing is normalized and it is stored in the queue, and this is what the line 17 describes. And then we have and then this whole part is used for constructing another triangular matrix called R. So we are creating another triangle matrix, empty triangular matrix R, and we are using two nested loops. Two nested loops fill R with dot products of the columns of A. So here the R the range of n and range of I, these are the range of I and j, and this particular matrix are filled with dot products of A and orthogonal basis vectors of Q. So that is what given in this line 21. And then the 22 and 23rd line are basically printing the Q and R matrices. So the result matrices are printed. That is what explained in the 22nd and 23rd line. And then input and function call. So the user is asked to enter a matrix which is evaluated and converted into a numpy function. So since we are using matrices, we are using eval function, which will be which will enable the user to perform functions very easily rather than using int function. And then in the final step we are and then in the final step the QR decomposition function is called in the matrix A. These are the test cases. This matrices are converted into these two types of Q and R matrices, and the same this matrix is converted to Q and R matrices using the Gram-Schmidt method. And the result, we have the result. Thus the algorithm using the Gram-Schmidt process is returned and verified the result. Thank you.